Hello, welcome to a quick video on inverses and inverse functions. We'll do this very fast. Hopefully you have a good understanding of an inverse moving forward. Right, if you just read that top line, it's a little covered up right now. It says, remember, okay, inverse functions undo each other. Okay, graphically, they reflect over line y equals x. And then it says what are some inverse operations you already know? Well, okay, what are some things that undo each other? So plus and minus, okay, add and subtract, or multiply and divide, those undo each other. Square and square root undo each other. Okay, those are all inverse operations. We use them all the time in math when we're solving equations. Okay, if you need to solve for x, okay, and there's a plus 5, you subtract 5, okay, because the negative is the inverse of the plus. It undoes it, leaves you with just x. Okay, real quick, we'll go through some of these things. Graph the relation and connect the points, then graph the inverse. Okay, so there's the relation. We need to graph it. So just real quick, let's do that. All right, there's those points graphed in red. Now I'll go ahead and graph the inverse in blue. Before I do, okay, if the inverse undoes each other, it's really just switching the x and the y. Okay, they're opposites, not the correct word, but kind of like the opposite of each other. So that first point becomes 2, 0. The second point becomes 5, 1. Okay, I'm just flipping it from what we saw in the original chart. Okay, and the next point, 6, 5, and 9, 8. And I'll go ahead and graph those. All right, there we go. Those are the points of the inverse. Okay, notice it's kind of like a reflection, and it's reflection through the line y equals x. Okay, so there's the line y equals x, okay, on forever in those directions. And it's just a reflection of the relation or a function through or in the line y equals x. Okay, we can easily find inverses when given a function or an equation. First, let's kind of look up here. To find an inverse, we need to first switch the x and the y, and then solve for y. And it's as easy as that. If you know how to literally rewrite x and y as the other one, and then solve an equation, okay, you can find inverses no problem. So let's real quick, I'll scroll up a little bit. We need to follow our rules here. So first one, switch x and y, then solve for y. Before I do that, okay, I'm just going to rewrite this as in red. This g of x is y equals 3 times x minus 7. Okay, and now in blue, I'm going to go through and do the second step of our instructions here. I'm going to solve for y. Okay, so switch x and y, bang. I just literally replace them with each other. Okay, now I got to solve for y. Well, that 3 is keeping it from, well, the y is right there. And that 3 and the negative 7 are keeping it from being alone. I can't get at the negative 7 yet because it's inside the parentheses, so I need to divide by 3. Okay, and that leaves me with x over 3 equals y minus 7. That's all that's left. Okay, now I can get rid of the 7. And I have x over 3 plus 7 equals y. That is the inverse. Okay, let's try the next one. Start in red again. Y, just rewriting, equals negative 1/2 x minus 5. First step, switch the x and the y. So I'll rewrite it as x equals negative 1/2 times y, then minus 5. All right, what are the things that are keeping this alone? The negative 5 is keeping it from being the y from being alone. The negative 1/2 is keeping the y from being alone. Okay. I can't get rid of the negative 1/2 right now. If I did, I would have to divide the whole thing by negative 1/2. Okay, and that doesn't cancel. All right, that would have to, now I'd have to divide to both terms, negative 1/2 y and negative 5, so that wouldn't work. So let me erase that. I need to add 5 to both sides first. Yeah, there's no, like the previous problem, there's no parentheses keeping me from getting rid of that, getting that 5 now. So do that, cancel, add 5. I'm left with x plus 5 equals negative 1/2 y. Okay. Now what? What's keeping the y from being alone on its side? Yeah, the negative 1/2. So I can divide by negative 1/2 to both, but that gets messy because now I'm dividing by a fraction and it just looks really gross. Or I can multiply by its reciprocal. So I multiply by 1/2, a negative 1/2, so we can cancel that negative as well, to both sides. So negative 1/2, multiply. Okay, what that ends up looking like is, excuse me, let me go back. Not negative 1/2, negative 2. Hold on while I get all of our work back that we just did. Okay, all the work's back. I accidentally erased everything. But we don't want to multiply by negative 1/2. We want to multiply by the reciprocal. Okay, so I want to multiply by negative 2 over 1. And what that does is these negative 2's will cancel. All right, I got to do it to both sides since I did it to one side. Multiply by negative 2 over 1. That leaves me with, well, negative 2 over 1 is just negative 2. So negative 2 in parentheses, x plus 5 equals y. Okay? Just clean it up real quick with the eraser. Okay. All right, last problem. Let's do just the h of x there. Okay. Again, first step to find the inverse is switch the x and the y. So let's do that. We call this x equals y minus 3 cubed. Clean that up. All right. Now I got to think, what is keeping the y from being alone? Well, the negative 3 and the cubed. So which do I need to get rid of first? Can't get rid of the negative 3 because it's stuck inside of those parentheses. That cube is applied to it. Okay, the cube's keeping us from getting rid of that first. So I have to get rid of the cubed. So what undoes a cube? That would be a cube root. So I have to cube root both sides. I didn't really leave myself enough space, so I'm going to rewrite this equation really fast. Okay, so I got cube root both sides. So I'm just going to do that. Cube root one side, cube root the other. And now, okay, that leaves me with, on the left side, the cube root of x equals, then on the right side, the cube root and the cube cancel, leaving me with just y minus 3. What's keeping the y from being alone? The minus 3, add 3 to both sides to get rid of it. And I'm left with y equals the cube root of x plus 3. That would be the inverse. All right. For this specific unit, we're not going to go much farther than that. So just examples of finding inverses. For graphing purposes, it's reflection over the line y equals x. Just switch the x and y's when given points. And for finding the inverse of a given function or a given equation, you just need to switch the x and the y and then solve for y. Okay? It's that simple, 2 steps.